Assalamualaikum and a very good day to our respected lecturer and fellow classmates. My name is Wan Muhammad Yusof Bewan Kamaruddin. I am here together with my group members Husna Hayati and Muhammad Aminul Naim. We are from Group 10. We are from class NAC 240B1C. Today we will be presenting our STA Statistic of Applications Group Project. The title of our project is a statistical analysis of demographic and financial determinants in loans application. Before we start, let me briefly outline the flow of our presentation. We will cover four main sections: introduction, explain the background, objectives, significance of our study. Second, the methodology, covering our dataset description, method of analysis, and software use. Third, the finding and discussion. Present both our descriptive and inferential analysis result. And finally, the conclusion, what we summarize our key finding and provide the recommendation. Moving to the introduction, the banking and financial sector revolves around credit intermediation, which is the process of channeling fund from depositor to borrower. However, lending always carries credit risk. Traditionally, banks rely on subjective assessment and basic demographic assumption to decide how much to lend. But today, the industry have shifted towards data-driven decision-making using big data and statistical software. There are several key issues in loan assessment. Overlending increases the risk of default, while underlending result is lost revenue from the bank. Education is often used as a proxy for financial literacy and stability. Income is assumed to have a direct proportional relationship with loan demand. The question is, do this traditional assumption actually hold up when tested statistically? But this is exactly that this study aimed to find out. In our study, we have three specific objectives. Objective 1 is descriptive. We aim to describe the demographic characteristic of the loan applicant, including their gender, marital status, number of dependents, education level, and employment type. Objective 2 is inferential. We want to determine if there is significant or not in the mean loan amount request between graduate and non-graduated. This test is the traditional assumption to education level affect borrowing behavior. Objective 3 is also inferential. We aim to examine whether there is a linear relationship between the applicant income and the loan amount they request. The test is common belief that higher income lends to the higher loan request. This study is significant to the three main groups. First, financial institution and credit analysts who can use our empirical evidence to refine their credit evaluation models. Second, future applicant and policymaker who can gain insight into whether demographic factor restrict access to the financial capital. And the third is the academic community, as our findings contribute to the body of the knowledge in applied statistics and financial analysis. So now let me explain our methodology. Our study used a secondary dataset obtained from Kelly, which is a well-known open source data repository. The dataset consists of 367 valid observations with no missing values. The variable included both qualitative dataset as gender, marital status, dependence, education, and self-employed status, as well as quantitative data such as applicant income and loan amount. For our analysis, We use IBM SPSS statistic due to its our friendly interface and capability to perform frequency analysis, independent sample t-test, and person correlation. As known in the table of Objective 1, we use frequency description, percentage, and then pie chart. For Objective 2, we use the independent sample t-test, and for Objective 3, we use person correlation. With that, I will now hand over to Husna, who will present the descriptive analysis findings. Thank you.
Thank you, Yusuf. I will now present the findings for Objective 1, which is the descriptive analysis of the demographic profile of our 367 loan applicants. As you can see from the key statistic on this slide, the data reveals some clear patterns. In terms of gender, 77.9% of applicants are male, which is 286 out of 367. This shows that males are the primary initiators of loan applications in this dataset. For marital status, 63.5% or 233 applicants are married. This aligns with typical financial behavior, as married individuals often need larger capital for family investment, such as homes and vehicles. More than half of the applicants, 54.8%, have zero dependents. This suggests a borrower base with potentially lower household expenses and higher disposable income. A significant majority of 77.1% are graduate, which is traditionally viewed as an indicator of stable employment, and 86.9% are not self-employed, meaning they receive regular salary income, which banks generally prefer. This pie chart provides a visual representation of the demographic distribution we just discussed. You can clearly see the dominant categories in each variable: male gender, married status, zero dependents, graduate education, and non-self-employed status. The visual dominance of these categories confirms that the typical loan applicant in this portfolio has a very specific profile. To summarize the descriptive findings, the typical loan applicant in this dataset is a married male with no dependents, who hold a graduate degree and works in traditional salaried employment. From a banking perspective, this profile suggests a borrower base that banks would generally consider lower risk, as they have stable income, fewer financial obligations from dependents, and higher educational qualifications. However, this also raises the question of whether this demographic characteristic actually influence how much a person borrows, which brings us to the inferential analysis. I will now pass over to Amirul Naim.
Okay, thank you, Husna. I will now present the inferential analysis for Objective 2 and 3. For Objective 2, we conducted an independent sample t-test to determine if there is a significant difference in the mean loan amount between graduates and non-graduates. Our null hypothesis H0 states that there is no significant difference, while the alternative hypothesis H1 states that there is a significant difference. Looking at the growth statistic, graduate requested a mean loan amount of 376.98, while non-graduate requested a higher mean of 605.25. However, notice is the very large standard deviation, 2,609 for graduates and 4,460 for non-graduates. This tells us that there is a lot of variability within each group. For the inferential test, we first check Levin test. The significant value is 0.195, which is greater than 0.05. So we assume equal variance. Then looking at the t-test result, under equal variance, assume the phi value is 0.557. Since the phi value of 0.557 is greater than the significant level of 0.05, we fail to reject the null hypothesis. This means there is no statistically significant difference in the mean loan amount requested between graduates and non-graduates. Although non-graduates had a higher average loan request, the statistical test proved that this difference is merely due to random chance and data variance. It is not a real pattern. The banking here is very important. Education level is not a reliable predictor of how much a person will borrow. Banks should not use education alone to forecast their lending demand. Now we're moving to objective 3. We perform a Pearson correlation analysis to examine the linear relationship between applicant income and loan amount. Our null hypothesis states that there is no significant linear relationship, while the alternative state there is a significant relationship. In the SPSS output show a Pearson correlation coefficient R of 0.117 with the phi value of 0.025. The key result show that R equals 0.117, which indicate a weak positive correlation, and the phi value of 0.025 is less than 0.05, meaning that it is statistically significant. Since the phi value of 0.25 is less than 0.05, we reject the null hypothesis. There is a statistically significant relationship between income and loan amount. However, the keyword here is weak. The direction is positive, meaning as the income increase, loan amount tends to increase as well. But the strength is weak. With R at only 0.117, according to correlation strength guideline, anything between 0 and 0.19 is considered very weak. The practical implication is that income alone cannot reliably predict how much a person will borrow. Other factors such as loan purpose, existing debt, co-applicant income and property value likely play much bigger roles in the loan amount. To conclude our study, let me summarize the key findings for each objective. For objective 1, the descriptive analysis showed that the typical loan applicant is a married male with no dependents, holding a graduate degree and working in salaried employment. For objective 2, the independent sample t-test found no significant difference in loan amount between graduates and non-graduates with a phi value of 0.557. Education is not a reliable predictor of loan demand. For objective 3, the Pearson correlation found statistically significant but very weak positive relationship between income, loan and loan amount with R equals 0.117 and phi equals 0.025. Income alone is insufficient to predict borrowing behavior. Based on our finding, we recommend the following. First, financial institutions should adopt multi-variable credit scoring model rather than relying on education or income alone. Second, they should explore additional variables like credit history, co-applicant income, and also property area. Third, future research should use a larger data set and advanced techniques such as multiple regression. And the last one is lending policies should not discriminate based on just education background alone.